Hi, welcome to the Interaxis YouTube channel, Interaxis.io. Today we're going to talk about Tellor. And Tellor is really important because what Tellor is a decentralized oracle that's used for getting off-chain data on-chain so it can be used in smart contracts currently on Ethereum. So that's a whole lot to unpack and a lot to explain. We're going to try to do it in a relatively short amount of time. So here we go. As most of you know watching this, when there are smart contracts, right? So if you have a smart contract, particularly one, in this case, on the Ethereum blockchain, this smart contract is a piece of software code. It's out there on the blockchain, on this interconnected web, this interconnected, essentially, computer, the Ethereum virtual machine, and it's out there waiting for its instructions to run. It's got its instructions, and in this case, it might be waiting for what we call an oracle. Okay, and what the oracle is going to do is it's going to feed some piece of data or some instruction to the smart contract to go do what it's supposed to do. What does that mean? Let's say that Adam and Ron have a bet going. Who's going to win the football game? Okay? Adam chooses Texans. Ron chooses Cowboys. Now, what happens here is we might make this bet. Okay, Ron and I agree to this. We might know each other, we might not. But what happens in Ethereum kind of smart contract world is this bet gets put into a smart contract. And this smart contract holds whatever we've bet. So in this case, we've bet 1 ETH. We each lock 1 ETH into this contract potentially. Okay, and it's sitting out there on the Ethereum blockchain, waiting to find out who won. Adam has Texans, Ron has Cowboys. It's all out here. It is looking for an oracle. In this case, let's say the oracle is ESPN.com. We've decided that the oracle is ESPN.com, and as soon as the score is final, then this score gets fed into the smart contract. This smart contract says, oh, look, the Texans won the game. This ETH is going to go to Adam's wallet. That's how it works. It's looking for an oracle. Now, currently, there's not really a decentralized way to get this data, this oracle data, onto this smart contract. This is very centralized. It's ESPN.com, owned by Disney. It's that company, right? So if we've decided that's the oracle, this is centralized. This can potentially be corrupted, manipulated, whatever it might be. Now, you might say, well, how can a sports score be corrupted or manipulated? The chances are it can't, but I wanted to show you what an oracle is like. So that essentially, this is an off-chain oracle, and we need to get data on-chain to make the smart contract work. But that's the essence of the type of smart contract we're looking at. Now, where might this be, something like these oracles be prevalent already? Well, let's say that instead of the bet we have, Adam and Ron have some sort of derivatives, some sort of contract that says as soon as the price of gold gets to 1,600, there'll be some options contract, right? If it gets above 1,600, if the price of gold gets above 1,600, then let's say that there's some smart contract that we've locked money in, and at this point, let's say we've locked in 1 ETH, and at that point, Ron has to sell me gold at that price. So the price of gold hits 1,600, Ron then has to sell me gold for $1,600. Okay, he's selling it to me. Now, we're looking for some sort of oracle. All the terms of this agreement have been locked into a smart contract, and we're looking for the price of gold to hit. Now, gold is not traded on the Ethereum blockchain. All right, now derivatives of gold can be traded on the Ethereum blockchain, but currently there's not much gold traded on the Ethereum blockchain, so we have to look outside. And we might look to some sort of service that provides that price. It might be an exchange, it might be Dow Jones, it might be S&P, whatever it might be, but we're looking off-chain, right? So this smart contract is on Ethereum, but we have to look off-chain to find out our oracle. Now, again, here's the problem. What if we can manipulate this oracle? What if we say it's some exchange out of, I don't know, we'll call it Panama. right? And I really want to be able to buy this, or Ron really wants to sell me this gold at 1,600. Well, isn't there a potential, right? Let's say Ron is a billionaire. He can go to this exchange, run the price up because he put so many bids in. He can run the price of gold up to 1,601, execute this contract, get rid of all his bids, and the price now goes to, say, 1,400 or something, and Ron's made some money. That is able to be manipulated. So that's why we don't want necessarily just one oracle. Also, this oracle happens to be off-chain, right? So how do we get this data on to this blockchain to execute this smart contract? Because a smart contract is supposed to execute automatically. We don't have to go hit a button necessarily to make it execute. The idea is we need it to execute automatically. That's what Tellor is trying to solve. Okay, so we understand that part. Now, Tellor wants to do it in a very decentralized way. Well, that's not very easy to do because there are only so many sources that you can get data from. So what happens now is the idea is you have these smart contracts that are looking for an oracle. You have all these potential data providers down here that all want to be the oracle. Okay, so Tellor has said, we'll be here in the middle. Our smart contracts will be here in the middle. And we have a way that we're going to be able to pull data from all these other people, and we are going to provide the oracle. Okay, Tellor is actually going to provide the oracle for the smart contract, but Tellor has gathered that data in a decentralized way to the point that if this gets manipulated, it doesn't affect the data that goes here because they're getting other data points. Now, the deal for Tellor is they have to figure out a way how to do this in a decentralized way where you still have the incentives to where these people don't want to manipulate. There's no one who can consolidate in here and manipulate the situation too much and get their particular price in because they might have this smart contract. And that's what we're really trying to guard against, right? Is if I have this smart contract and this data, how can I manipulate in order to help myself out? That's what we've seen somewhat in the decentralized finance world, and we don't want to see it anymore. And it's really hard to figure out what the incentive structure is to get people to act in the correct manner, because this can all be done programmatically in a matter of microseconds or nanoseconds, and before you know what hits you, people have lost money. So, again, here's the kind of ingenious way Tellor has decided to get off-chain data decentralized and on-chain. So you have two groups, right? You have the groups over here that need data, need an oracle. And what they're going to do is they're going to put in kind of orders, right? There's a block, a Tellor block is processed every 10 minutes. So these folks, these contracts, whatever it might be that need data are going to basically put in project bids, right? They're going to say, we need the ETH USD price, or we need the Bitcoin USD price, or the gold USD price. And they're going to put money behind it, right? They might put 10 tribute tokens. Tellor has their own token called the tribute. They might put 10 tribute tokens here, and 5 here, and 5 here. Now what's going to happen is this all kind of gets thrown into the system. There might be others. So one particular exchange or smart contract might say, we're willing to pay 10 tribute tokens for anyone who can provide this ETH USD data. 5 for Bitcoin, 5 for gold. And there might be others that go, look, I'll throw in another 1 tribute token. I'll throw in another 1 here. These are called tips. Okay? So here's what happens. This goes in here. Every 10 minutes, one of these is picked, the one that has the most money allocated to it, the biggest project, right? Goes in here. Now you have a series of validators coming in. So now you've figured out what the project is that's worth the most for the system. Now the system goes, okay, we got to figure out the ETH USD price. All our validators tell us your price. Here's what you have to find. They tell us the price. But there's some staking involved. And the staking is all these validators have to put up 1,000 tribute tokens to be able to submit their number, their data. So they're going to put in 1,000, all these validators put in 1,000 tribute tokens, and we'll talk about that in just a minute, why that's important. They've staked 1,000, right? And then what they're also going to do is once they've done that, they're going to solve an algorithmic problem, right? So now we have proof of work. They actually have to do some work. And the reason why they're doing that is so they can't submit like 1,000 different data points hoping that Tellor chooses one. They actually have to do some work. It's going to cost them some time and money and energy. And in addition to that, they have to give the answer. It is, 150 USD per ETH. Okay? So all these validators, they stake their 1,000, they solve the proof of work problem, they put in their number. Okay? Of all of that, they're going to be 5, the first 5 that come in. Okay? And there's a reason why, Tellor has chosen not to go with just 1, but 5. Okay? Now, Tellor is going to look at those 5. Did they stake? Yes. Did they solve our proof of work algorithm? Yes. What is their number? 150. So let's say it comes in at 150, these 5, 151, 150, 152, 149. So Tellor is going to say, okay, if we line these up, it's 150, 150, 150, 150, So the median price, they're going to line these up. 149, 150, 150, 151, 152 in numerical order. And they're going to pick the median, right? So the median was 150 US dollars per ETH. So that is going to be the number that gets used. It's going to be fed to the smart contract. $150 is the number, but the number came from Tellor, not from this particular data point. So why is all that important? One, all these 5 validators that were chosen, the 5 that did all this work, they're going to get to split all the tribute tokens equally. The reason why Tellor does that is because they don't want to give incentive just to 1. They want the incentive to be equally across all 5, and that way they'll get a better number because they're going to pick the median. This number was just as important. This number was just as important in getting a good median as the one that was actually chosen. Therefore, they all get to split it equally. Now, the staking is important because if some validator always is trying to get in with, be one of the first 5, and they keep giving a bad number, well, with the staking, you can actually challenge the number, the data that some of the validators are giving. You can challenge the data, and if you challenge it, there's a way to actually take this stake away from them. Okay, so the staking is there so that the validators won't put in bogus numbers necessarily because they can be challenged and they can have their stake taken away. So another issue Tellor had to run into is, okay, what happens if since submitting the data actually goes onto the Ethereum blockchain, and you can go on and look at all the transactions in the blockchain, especially the pending ones, what's to keep someone from running, from trying to jump ahead and saying, okay, you submitted 150, it's sitting out on the blockchain waiting for the transaction to clear. I'm going to jump in line in front of you, pay more gas, and I'm going to submit the same thing that you do. Well, one thing is that's why they're allowing 5 and not just 1. That's one way to get around that incentive. Something else Tellor is doing is if someone did that, right? If one validator submitted 150 and I went and looked at their transaction and cloned 4 more and threw them all in so that I have 4 out of the 5, but I didn't actually do any work. I just copied and pasted what they did. What Tellor has done there, that's one reason they actually reward all 5. Right, but what happens is the next time through, since that 10-minute block was probably only took like a minute to process, the next time through the process, the next block will actually get a little bit easier. Meaning more people are going to be able to solve the proof of work algorithm to be able to get in, so I can't necessarily do my 4 anymore because there might already be 4 spots taken and maybe I only get 1. So that's the incentive there, is the proof of work algorithm is going to change after every block or every so many blocks, so that if someone's trying to front run, now the proof of work algorithm gets easier and more other validators can get in. They've had to solve that problem. There's a problem with mirroring, right? The mirroring is I'm just going to read someone else's entry and copy and paste and submit it as my own. So what Tellor's doing occasionally there is they're going to get in the system personally and they're going to throw some bad data in. And what happens is if I mirror the bad data and I've staked to it and I get challenged, I lose my stake. So there's not much incentive for me to do that. Tellor's had to think of all these incentives so that they can take all this data from off-chain and get it on-chain to be able to make these smart contracts work. This is actually really brilliant and really necessary because not as much now, but in the future there's going to be so much off-chain data that's going to have to get on-chain in order to facilitate smart contracts, right? So right now it can be used with we see the potential obviously with financial derivatives, right? As I talked about, either ETH USD, Bitcoin USD, or even gold USD if you're trading like synthetic assets. So obviously finance is a big use case. Insurance, we think, will be a big use case. And the reason is, let's say there's some decentralized insurance on crops in Africa or something, and you need to get data from certain areas of Africa to see if there's actually a drought, see how much rain there is, to see if insurance should pay out. Well, you're going to have to get, say, rain data or wind data or something from somewhere. Well, you're going to have to get all that off-chain data on-chain to facilitate these smart contracts. And again, Tellor has found a way that they can facilitate that. They utilize their own token for tracking purposes and everything. They utilize their own token for everyone to be able to stake and do the tributes and pay for the actual data in a really good way so that they get this decentralized off-chain data. It's really a hard concept and a hard thing to do, and Tellor's done it. Now, the question is, can they actually do this on other chains, right? Because other chains are building different DeFi type applications. And that's the next step they're working on, right? So the next step of Tellor, you're going to have your tribute tokens, which are all going to be tracked on the Ethereum blockchain. They're all going to be on Ethereum because you don't want to have tribute tokens here and tribute tokens on some other chains that are providing decentralized finance type applications. So you have this other chain over here. You don't want to have a Tellor token here and a Tellor token here, a tribute here and a tribute here. And the reason is because, one, the price to dollar, the price to Bitcoin might not match up. And it decreases the security, because if you have a really good security here, you might not have security of the token and the monetary policy over on this other chain. But what's going to happen is there have to be a token bridge here between the Tellor tokens over here and this bridge, and then over here you have your token bridge, so you know how many tribute tokens someone has, and then the smart contract lives over on this blockchain. All the validators are on this blockchain. They're going to get paid in this kind of synthetic tribute, this tribute that works on this chain, and then they're going to be able to take it back over the bridge and convert it. So you can do all the same process all over on this chain, and then you just have to get back into your Tellor, your tribute tokens that exist over here on Ethereum. So that's what Tellor's looking at. Really good, interesting project from some folks who really have put in the time and the effort and really have the expertise and experience based on their backgrounds to be able to do this. So we really like Tellor. We really see the need for the decentralized oracles to come into existence so that we can get more on-chain tradings, more decentralized finance, smart contracts that are not only crypto-based, but they can function on other financial assets or other products, other things like insurance that we see, oil and gas that we might see later, because you're going to have to get that off-chain data. So that is a bit about Tellor. You can find us, subscribe to our YouTube channel, Interaxis.io. Is our website, at Interaxis8. The number 8 is our Twitter handle. We hope to see you in the next video.